Hello, I am Inseop Chung from Seoul National University, and I'm going to talk about my paper, Maximizing Cosine Similarity Between Spatial Features for Unsupervised Domain Adaptation in Semantic Segmentation, accepted in WACB 2022. Daesik came from Naver webtoon, and Professor Nojun Kwak are my co-authors. Unsupervised domain adaptation is a statistical of training a model to perform well on the target domain, which has no ground truth labels, by adapting the knowledge model has learned from the source domain, which has rich GT labels. It is a challenging task since the target domain has no access to ground truth labels. A segmentation network consists of two parts, a feature extractor and a classification head. Our idea is to bridge the domain gap between the source and the target domain at feature map level via maximizing cosine similarity between semantically related features. We compute a cosine similarity matrix between the flattened source feature map and the target feature map. Each row of this cosine similarity matrix shows how each target feature is similar to each source feature. From the cosine similarity matrix, we select elements that are higher than predefined threshold, and then maximize those elements to 1. Therefore, the target feature can be maximized with similar source features that have high semantic similarity. We call this cosine similarity loss. However, with this approach, there is a problem. If a certain class only appears in the current iteration's target image and not in the source image, for example, like the car class of the target domain in this picture, there could be an unmatching problem, where the target feature of that class do not have any source features to be maximized with. To address this issue, we propose class-wise split and the use of source feature dictionary. We split the source and the target feature map by classes first. For the source domain, we split the feature map based on the correctly classified predictions using the ground truth labels. For the target domain, we split using the pseudo labels or the prediction output of the network when pseudo labels are not available. Then the split source features are stored in the dictionary in a first-in, first-out manner. The cosine similarity loss is computed between the split target features and the source features stored in the dictionary for each class. We then take an average of all classes for the final cosine similarity loss. By using the source feature dictionary and class-wise split, unmatching problem can be avoided and the target feature could be maximized with more variety of source features. The overall loss terms are defined in two forms, when the pseudo labels are available and when they are not. When pseudo labels are available, we additionally employ self-training loss on the target domain and use them to split the target feature map. We compare our method with other state-of-the-art methods and show comparable performance on two UDA benchmarks. Also, we conduct experiments without using the pseudo labels of the target domain and compare with adversarial adaptation that is widely used. We show that our proposed loss can outperform the adversarial adaptation method, which is known to be difficult to train. In the Ablation Study, we remove each building block of our contributions to see its effectiveness. As it can be seen in the figure, in the table, the performance degrades as we take out our contribution. Interestingly, when we apply the adversarial adaptation along with our method, the performance rather decreases, which tells us that using adversarial adaptation interrupts the training when used together with our method. As a conclusion, our contributions can be put in threefold. Our method measures the cosine similarity between a target feature and every source feature spatially by classes and selectively maximizes the similarity only with the most semantically similar source features. We propose source feature dictionary to maintain the latest source features, which enables target features to be maximized with various source features and prevents the unmatching problem. We empirically show that our method can replace the unstable adversarial adaptation, which is incapable of selectively adapting the target features to the most related source features. Thank you.